Assalamualaikum. My name is Mohd FAZLI bin USIN, FTKEE BEI student. My supervisor is ADLAN bin Ali. So for my BDP1 title is Energy Storage System of Regenerative Braking in Urban Railway based on supercapacitor. So for the background, nowadays with the growing renewable sustained energy, the demand of electrical transport system is increased. Okay, because of the system prevent environmental pollution, also reduction of energy consumption, and the electricity is cheap compared to fossil fuel. Okay, when a train in operation in braking mode, it can efficiently recycle braking power as regenerative power, which can be fed back into the catenary used by the train itself or stored in energy storage. So for the supercapacitor is an energy storage technology that is rapidly developing and being implemented in various industry application. So for the generated braking energy is produced by dropping down the train to the lower speed, but at the same time it still need a friction brake to make sure the coach in the completely stop and as a backup system while regenerative braking malfunction, and this energy can be fed back to the DC line voltage. For the problem statement, during regenerative train braking, the kinetic energy of the train is converted to electricity that can be used or transferred to another system when needed. As an urban rail transit, this railway system needs frequent startup and braking. Traction power supply substation cannot absorb energy in reverse direction. The excess energy generated during regenerative braking cannot be reused, resulting in energy wasted. Okay, so for this research, we'll study the regenerative braking energy absorption based on supercapacitor and store the excess energy generated during regenerative braking into the supercapacitor energy storage system. Okay, for the objective to develop the effective energy management for reduction of energy waste and consumption on urban railway. Second, the access the efficiency and the effectiveness of supercapacitor energy storage system in regenerative braking system. And lastly, to design the simulation modeling of energy storage system using supercapacitor. So this objective we will discuss on the methodology part later. Okay, for the scope of research, the study the regenerative braking energy absorption and utilization technology based on supercapacitor and store the excess energy generated during regenerative braking into the supercapacitor energy storage system. Second, review of the various aspects related in reduce energy consumption of a train by using supercapacitor energy storage system. And lastly, investigation the efficiency and the effectiveness using supercapacitor. So the methodology, okay, this is the flow chart. First, I'm analyze the actual energy consumption and then railway power supply, and then track energy consumption, and then for the regenerative braking on board energy system storage, supercapacitor, and then we will discuss about the efficiency and effectiveness, and lastly the circuit modeling. Okay, for the track energy consumption, this research based on Malaysia trend. So I will use the KTM class 93 railway electrification in Malaysia, the KTMB. So for the KTMB class 93 model is the second generator of electrification train into service on the 3rd September 2015. So the traction system is AC and the power output is 3200 kilowatt and 25 kilowatt and 50 hertz overhead line. So this is the standard main supply for Malaysia. Okay, for the railway power supply system, the class 93 use traction power distribution system and powered by electric from catenary overhead line. So for this research, I will starting with the catenary because the main supply for the class 93 is AC. So this research fully discuss about the DC power supply that started from the catenary overhead line. Okay, this is the pantograph and the overhead line system, and this is the pantograph closed loop. Okay, for the regenerative braking energy recovery, okay, the main problem for this research is from the regenerative braking energy. Okay, regenerative braking system allow recapture the kinetic energy during the braking and store it in supercapacitor rather than converting it into heat loss as in the conventional braking system does. So when the train started to brake, then it will apply regenerative braking system. The system put the train electric motor in reverse mode, which causes the train motor to run backward. At a certain speed, the brake is applied. The momentum of the train causes it to slowly declarate when the electric motor running in backward. So for the same time, while the electric motor running backward, it also acts as electric generator, produce electric and store it in the supercapacitor. In order to maximize the use of recovered energy, this research regenerative braking energy will be stored using energy storage system that we'll discuss next. For the energy storage system, I will choose the onboard. The onboard location is on the top of the train. So the cost of the installation is not so big like other energy storage system. So the outstanding advance in both power electronic and energy storage technology have enabled ESS can become an excellent option for using regenerative braking in urban rail. Okay, for the energy storage technology, I will use supercapacitor as to store the wasted regenerative braking energy. So for the supercapacitor, also known as ultra capacitor and electrochemical capacitor, the best way to deal with regenerative braking energy is to store energy in supercapacitor CDL capacitor. The main idea of this energy storage system are factors like power density and energy density. The reason choosing supercapacitor is because of long time, lower size, and weight, easy to control, easy to calculate state of charge of elements, and other. The supercapacitor in railway system, we will discuss the main character, the effectiveness, and the efficiency of the supercapacitor. So for energy density and power density, energy density describes to the energy storage ability of a technology. Supercapacitor can store energy and how far the train can travel. And the power density describes how quickly the device can deliver energy. So this is the comparison of energy and power density of the ESS system. As you can see here, the EDLC energy density is only 5 to 15 watt-hour per kilogram. The energy density is lower than battery and other application, but the power density here is 5,000 to 10,000, much higher. That is, supercapacitor can charge and discharge more quicker. This means they can be used to power application that need high peak power like train. So for the energy density here is 10 to 30 and the power density is more than 100,000. So for the cycle efficiency, it have three types. So for first, very high efficiency is greater than 90. Then second is high efficiency 60 to 90%, and lower efficiency is lower than 60%. So from this table, you can see the EDLC cycle efficiency is 90 to 97% with the lifetime 10 to 30. So with this lifetime, we can manage to cut or to reduce or to save more maintenance costs in here. And the life segment here, the charge and discharge can be done more than 100,000 until million times. Okay, for the self-discharge and storage duration here, as you can see here from the photo, the charging mode, the regenerative braking energy will store in the ESS, and for this charging mode, the process started from the energy from the ESS and supply for the acceleration of the train. So in this process, the catenary will be free. For the self-discharge here, the EDLC only need 20 to 40 millisecond to minute only. So it can charge quicker from even short period of braking and can discharge with high power density when needed. So from that, the overall effect is stabilize the output power of the main power source. The main supply can be improved this way. So the environmental impact is another key factor in determining if an ESS can be utilized in large-scale application. So from this table, the EDLC only slide. So slide here mean it don't release any carbon monoxide like battery. So the EDLC is environmental friendly, and the more advantage on it is supercapacitor don't have any problem with any weather, hot or cool weather. It can work 100% good. Okay. Okay. For the modeling scope, uh, I'll be using MATLAB and Simulink or the PC software to develop the circuit. And the circuit modeling here, the control strategy of DC to DC. This is the control principle when the supercapacitor is charging. So in the process of braking, the motor is generating electricity. The energy produced during this interval is called regenerative braking energy. Okay. And this is for the control principle DC to DC converter when supercapacitor is discharging. So for the circuit, I will using the IGBTS as the turning on and off for the duty cycle. And the current in the DC converter become full setting current. The output current maintained continuously smooth because of the presence of the inductance coil, freewheeling diode, and filter capacitor. So for the circuit, I will do it on the next sem. So for this BDP1, I will discuss only until the circuit modeling. Okay, this is the project planning for my BDP1 and BDP2. And this is the Gantt chart for BDP1 and my BDP1 planning. So that's all from me. Thank you.